Hello and welcome to another conversation with the team from EAR. So in today's conversation, we're going to talk about what AI can learn from HPC. And today we're joined by Julita, who is EAR's CTO. But before we get into things, I'm going to quickly ask Julita to give a quick introduction about herself.
Hello, my name is Julita Corbalán. I am the CTO of the Energy World Solutions here, and I am also associate professor at the Polytechnic University of Catalonia and researcher at the Barcelona Supercomputing Center.
Okay, so you've been working in HPC for a long time, long before AI went mainstream. So what similarities do you see between the two fields?
Yeah, so Fran, if we manage to, let's say, abstract the details and the terminology and the specific use cases, I think we are in very similar scenarios. I mean, at the end of the day, we have the low-level resources like CPUs, GPUs, which were already existing in HPC. We have the data center infrastructure, that, of course, we want to get the maximum benefit, the maximum performance. On the other side, we have users. So right now there are, let's say, human beings as users, but also some agents and so on. But it's similar, not the same, some differences, but similar. And then we also have, of course, the workload. So the final goal, the final objectives in HPC and in AI is the same, is to run these workloads in the most efficient way. So what is a bit new, not really new, but that gets more relevance, more importance in the new scenario in the game, is being more energy efficient, the execution in the most efficient way of these workloads in the existing infrastructure. But this goal, these actors were already existing in HPC.
Okay, so what AI problems surprised you because HPC had already solved them years ago?
So I will not say HPC already solved these problems, but interesting lessons learned from HPC, because HPC is still evolving also, is the fact, in my opinion, there are two very important items or ideas, let's say, that in HPC we have been working for a long time, and they are being applied also in AI. Is on one side, I would say the virtualization or the isolation of the resources. In HPC, for example, MPI applications, everybody knows that MPI applications in an ideal scenario, they should run isolated in exclusive mode. It's what it was said in HPC. So in AI at the very beginning, it was maybe in a different configuration, but right now it's on one side, the isolation of resources, and in the other side, the sharing of these resources, which was also existing in HPC to get the maximum benefit. And then in HPC, we were referring to that as oversubscription, okay, or other terminologies, but the same ideas. And on the other side, it's the fact that the HPC user has a lot of expertise. HPC users, final users, and the sysadmin. So I think in HPC, everybody was having clear that the expertise of the people using the system was key to get the maximum performance. So probably the expertise, the skills of final users using AI system is completely different from HPC. But at the end, I think we will go in the same direction of providing as much as possible trainings, training and letting them know how to really use the system, because doing in a more agnostic way, I think is not the solution, and that will not work. In AI, we have the benefit, but not only in AI, maybe also for HPC, that right now we have these new agents, these new orchestrators, these new engines, like are kind of super users. So it's the probability that they really learn and they really know how to get the maximum benefit of the system is higher than just with regular users.
Awesome. So what I'm interested to know now is, why are job scheduling and workload management becoming so critical again?
Well, in fact, because they have been always so critical. I mean, they were critical, 50 years ago, 20 years ago, and they are critical now, and they will be in the future. Take into account that the only way to guarantee that you are doing a good utilization of the system is controlling the access to the resources. So imagine in a building with no one controlling the door. There will be no way that you have an efficient distribution of people in the building, for example. So that has been always a must, to control the access to the resources, to guarantee the access and the utilization is in the way that every workload requires. So it could be either isolated, as I was saying before, like in exclusive mode, or in a sharing mode in case the utilization of the resources that you require, they are not enough to fill or to get the maximum performance. But the control, and control means the job scheduling or workload scheduling, it has been always critical to guarantee this efficiency in the system. So it's not a new problem. It's a problem that I think we forgot from time to time. It's super important, but it has been always critical.
Awesome. So I'd like to also share with us, what can commercial AI infrastructure teams learn from supercomputing research?
So in my opinion, what we should, let's say, maintain or even improve is of course, the expertise. Probably this is what you are asking, which kind of expertise, no? So I think it's the way these HPC data centers, they are managing the center itself. So they have years of experience and they know how to create different departments, like differentiating, for example, the teams that taking care of more infrastructure level, like the cooling, for example, or more electrical things, from what is the computational part, from the user support team, and also these activities, these ongoing activities they are taking care of, like this training for users, for tools, for applications, workshops, this research oriented activities that they do, because in HPC it was a scenario, let's say, or a context that it was mostly research oriented. So one of the differences is that in AI is more business oriented, maybe, okay, but I think the way, as I said, the way it was managed, the professional way they were taking care of the institution itself, and never forgetting about this research mind, some way to progress. I think that is something that we should not forget about, and we should learn and get the best of this expertise, of this experience for so many years in this new infrastructures, new data centers.
Great. So where does EAR fit into the HPC AI crossover? And how does it bring proven HPC energy principles into modern AI clusters?
So what EAR brings to these, let's say, scenarios is that we are able to get the ideas of energy monitoring, energy accounting, energy optimization, which are valid for any scenario. So if you remove AI or HPC words from the conversation, it's still valid. So what we do is that we get the expertise, the technology, the low-level technologies, and all this expertise we bring to AI. We make it, let's say, for users or for institutions that have the two types of infrastructure. We bring also the fact that we say is the same tool. So the APIs, the user interface is exactly the same. And then what we do is we adapt to the specificities of the new infrastructure. So of course we adapt to the resources, even though GPU was already existing on the HPC infrastructures. But the main difference is that the users, so these different users I mentioned before, and also the workloads. So of course the workloads are different, and we need to understand which are the key metrics, the KPI, the indicators that will drive us, will guide us to implement the energy optimization. Okay. But again, it's a matter of detail, very complex details, very sophisticated details, but at the end of the day, the ideas are the same. We need to monitor at runtime, workloads and infrastructure. We need to do the accounting because we need to know what are we doing and what are we consuming. And we need to dynamically adapt the configuration to the workload activity. So these main, let's say, features are valid both for HPC and for AI. And this is what EAR is doing. We are bringing all the expertise we have, all let's say, these items we know we have to do and that we were doing in HPC, and we have migrated to AI, and then we have adapted to the AI characteristics.
Great. So what I'm interested to know now is, if you're designing a large compute facility today, with everything you know from HPC, what would you do differently?
So what I will do differently, but not only about EAR, about the design of the whole infrastructure, as you say, is something that in HPC we have been discussing and trying to apply in projects for several years. Is what we call co-scheduling. Co-scheduling means that not designing independent parts of a system, a cluster, data center, whatever, to connect the different parts of the system. This is very difficult. In HPC, we have been doing in different parts, like for example, doing co-scheduling between applications and system software, runtime libraries, and final users, cooling, and compute systems, for example. But what will be super powerful and what will make the difference is do a real co-scheduling, taking into account all the components. So, for example, one of the limitations that we face in energy management and optimization is that there is no way to access to some parts of the infrastructure. So, for example, there is no way to monitor the energy consumption or the performance indicators for the cooling system because it's not designed to offer this API, to offer this information. So it's a design done, for example, by a company, and it's not targeting to be managed or to be exposed to other parts of the system, or, for example, internals of the hardware. No? So this is really, really challenging. It's really difficult because, as I said, that will imply the cooperation of different companies. In cases, very big companies like hardware vendors, for example. But I do think it will make a difference if there was this design from scratch, taking into account all the expertise and this interaction, as I say, co-scheduling, co-design, holistic systems, all these let's say expertise and all this knowledge that we know in HPC, but it has been impossible to apply in HPC system. If it was possible to do really something from scratch with no limitation, this is what I will do to create like a big team involving different companies and creating this really, really holistic data center with a real co-design.
Okay, so that is everything for today's episode. So please give us a like, a subscribe, or a follow. Until next time, thanks very much.